All right, guys, let's continue on with our factoring, and let's start with a warm-up example here. Can we factor x squared minus 7x plus 10? So let's think about what are we looking for in order to make this thing factorable. Okay, so again, since it's a quadratic trinomial, right, we know that it's going to start with x and x because when we do our FOIL method, that's where we're going to get the x squared to come from. And then the little trick for the rest of these is we need to figure out what goes here and here, and they need to multiply to be that positive 10, and we need them to add up to the negative 7 in the middle. Okay, so we can kind of make a little list over here, factors of 10 that add up to negative 7. So like 10 and 1, 5 and 2. Okay, we could use the 5 and 2 as long as we make them both negative, right, so that they will add up to the negative 7. So we could go with x minus 5 and x minus 2. Okay. And again, the order does not matter. We could do x minus 2 first and then x minus 5. But they both do need to have the minuses in there in this case. All right, and also as a reminder, you can always check factoring by actually multiplying it back out and see. So I would encourage you guys, if you're having a little trouble seeing how this works, distribute it back out and it will kind of help you figure out why we did the process that we did as far as finding factors of 10 that add up to negative 7. Okay, so let's take a look at the next example here. This is one that our friend Jim factored. Let's see, is Jim right? Okay, so he said 3x squared minus 17x plus 10 would factor into 3x minus 2 times x minus 5. Okay, so we can check it again by foiling it out. So let's take a look. If I take the 3x times x, we will get 3x squared. 3x times the minus 5 is minus 15x. Then we'll distribute the negative 2, multiply the negative 2 times x, and the negative 2 times negative 5. Okay, carefully we get this positive 10. So, combining the middle terms, we would get 3x squared, we'd have a negative 17x, and we would have a plus 10. Okay, and that was what the original expression was, right? So our buddy Jim's on the ball. Jim knows what he's doing. Okay, Jim's pretty sharp. Now the question is, could you have done that? Could you have come up with these factors on your own? Okay, so let's see, kind of like how we did the previous one, you can kind of look at I need a 3x squared, so you could kind of say, well, I know that I need a 3x times x. 3x times x would give me the 3x squared here. The minus 2 and the minus 5 do multiply to be the positive 10, but they don't add up to the negative 17 like they did in this one when they added up to the negative 7. Okay, and the difference is this is a leading coefficient called the a value, because the general form is going to be ax squared plus bx plus c. So whatever that coefficient on the x squared is, in this case it's 3, we call that the a value. And we've only seen at this point problems that have an a value of 1. Okay, so things change a little bit when it's not 1. So I want to give you guys a method on how to factor these because there is a process to try. Now just keep in mind, not everything is factorable, right? Some things are prime, just like numbers. Like the number 7. You're not going to get factors other than 7 and 1. Okay, sometimes that does happen. But a lot of things are factorable. So let's walk through a process I kind of like to use, and we'll get the job done when it's possible. All right, we're going to use this method that involves grouping. So grouping is kind of a different method. Grouping can be used in certain cases. And the method I want to give you to do the quadratics are going to involve grouping. But this is not a quadratic, right? This is a third-degree polynomial. But the method of grouping applies and looks kind of nice here. So again, anytime you're doing factoring, you always want to look for a common factor. So I'm looking at, I see 4 terms here. Is there anything that goes into all 4 of them? Okay, unfortunately not. But if we think of this as 2 distinct groups, okay, meaning there's one group of terms, and here's another group of terms. Okay, sometimes you can factor by the groups and then kind of get the whole thing factored. So let's take a look. In that purple group there, both of those terms have a factor of 8 and x squared. Okay, 8x squared is the greatest common factor in each of those. So I'm kind of ignoring the green stuff, and I'm only factoring the purple. So I can factor out an 8x squared To get it back up to 24x cubed, I would need to multiply by 3x. And I do need to have a minus 1 there to get the 8x squared back. Okay, so that green part, or that purple part, is done. Okay, now we have a minus sign in the middle, and the green highlighted terms have a common factor of 5. So if we factored a 5 out, how are we going to get back 15x? We would need to have a 3x here, and then I would need to have a minus 1 to get back the positive 5. Now just keep in mind here, this is a minus because we had a minus here, so the minus 5 times minus 1 does get us the plus 5 there. Okay, so just kind of watch your signs and be careful. But once you start doing grouping a little bit, you will notice that this is the kind of thing you want to have happen. You want each of the terms to now share a common factor. Okay, and sometimes they don't, but many times they do. And when they do, we now treat the 3x minus 1 as a common factor because both terms do have it. Okay, so I'm going to factor out the 3x minus 1 in both. And the leftover, look at the purple term. If you take the 3x minus 1 factor out, you're left with 8x squared. And if you take the 3x minus 1 factor away from the green stuff, you're left with minus 5. And this is now factored. Okay, it is a straight multiplication problem, right? It's one term times another term. Right, it's 3x minus 1 times 8x squared minus 5. Okay, and if we just want to verify just to check and see it, okay, it's not something you got to do all the time, but just to check and make sure since it's the first time, let's FOIL out our answer and make sure we get the original expression back. Okay, so do the FOIL process. The 3x times 8x squared, there's your 24x cubed. The 3x times minus 5. Okay, the minus 1 times 8x squared. And then the minus 1 times the minus 5. Okay, and compare that to the original expression. Okay, it's not in the exact same order, but it's still the same, it's still equivalent. Okay, so that's just the way to check it. Okay, so I want to give you guys one to try. Let's try the grouping. So jot this one down, pause the video, and see if we can work this next one out. All right, so hopefully you had paused it and tried it out. Let's try and do this on our own. Okay, so again, I'm looking, I don't see a common factor for all terms, but if we do the grouping in two separate groups, okay, we might be able to work it out. Let's see. So the first two terms, 12n cubed and 30n squared, I know a common factor of each of those is going to be 6n squared. That's the greatest common factor, right? That's the greatest thing that goes into both. And we would need to multiply by 2n and minus 5, okay? And just stop and take a second, check that, distribute that back in your head. See how you're going to get the 12n cubed minus 30n squared back, okay? And then for the other term, 10n plus 25, 5 goes into both. So I'm just bringing down that subtraction sign. I'm going to put the common factor of 5 out front. And let's see, what else would be here then? 5 times 2n. And then to get a positive 25 back, I would need to do the negative 5 on the outside times another minus 5. Okay, and now we kind of know we're on track because both terms now share this common factor of 2n minus 5. Okay, so we can bring the common factor out front, just like we did on the previous step. Always bring the common factor out front. And now looking back at each term, if you took the 2n minus 5 out, you would have the 6n squared and minus 5. Okay, so that would be fully factored. All right, so again, that's grouping. We're going to take our problems, okay, like this. This was the one that Jim did for us, and we checked and saw he was right, but how could we have done this on our own? Okay, so it's a little bit more complicated again because there's a 3 there. Okay, so here's the process I would suggest you guys do. And you're welcome, there's other methods. There's like a box method that I don't know if you've seen Algebra 1 or in our textbook they might show where you can kind of use a factor box and do some things, and that's fine. I just want to show you the method I kind of like best because it just ties right into that grouping method. So here's the process though, what you're going to do. And this will work even when even if the coefficient here was 1, like we did in the first part of the section, this method still works. It's just not really necessary, but it will still get the job done. Okay, so what we're going to do, we're going to take that 3 And let me just label this again. Remember, this is going to be ax squared plus bx plus c. That's just the general form for a quadratic. So what we're going to do is we're going to take that a value times the c value. Okay, so we're going to take 3 times the 10, and we're going to get 30. Okay, and what I'm going to do now is I'm going to split up. I'm going to get factors of 30, just like before now, that add up to the negative 17. Okay, so the only difference is not just factors of 10 like we did in the warm-up problem. We need to incorporate this a value of 3. So 3 times the 10 is 30, and let's split up 30 in a way so that the terms add up to negative 17. Okay, so with 30 we could do 10 times 3, 15 times 2. Okay, and I'm seeing I need to add up to negative 17, so negative 15 times negative 2 would be positive 30, and it would also add up to the negative 17. So what we're going to do is we are going to split this middle term up into 2 terms. Okay, so bear with me here. We're going to have the 3x squared first. I'm splitting up this negative 17x using the 2 numbers we came up with over here. And it doesn't matter which order you do it in. Okay, so all I did, let me just recover what we did. I took this term right here, and I split it up into these 2. Okay, that's just the negative 17x. Okay, so we see that. The reason I did that and what it's going to let us do now is we are going to be able to do the grouping method. Okay, I now have, once we get to this step, we have 4 terms. So I can do that group and that group, and I can factor each of those. And it just, if it's factorable, this is going to get it done. So looking at the 3x squared minus 15x, I know the greatest common factor of those 2 is 3x. And I would be left with x minus 5. Okay, that's the first 2 terms. Then there's that minus sign in the middle. The 2x plus 10 has a common factor of 2. And we would be left with x minus 5 again. Okay, now we know we're in business because both terms have an x minus 5. That is now a common factor. So bring the common x minus 5. See, they both had one. Bring that out front. And then you're just left with 3x and minus 2. Okay, and that is the factored version of our original expression. Okay, that's what Jim got, right? That's what Jim had in the warm-up. Now, you may write the 3x minus 2 first if you want to. It really doesn't matter. It's a parenthesis there. Times x minus 5. You can write it. What is going on? There we go. You can write it any order you want. Because, again, multiplication is commutative, right? A times b is the same as b times a. So either way you want to write it, those are the factors. Okay, so let's try one more. All right, let's give this one a shot here. So 4x squared plus 5x plus 9. Okay, so what I'm going to look for first is I'm going to multiply, since there's a 4 there, I'm going to multiply 4 times the negative 9. That is going to get me negative 36. Okay, I'm going to split up negative 36 into factors that add up to positive 5. Okay, so with 36, I know we have 9 times 4. Okay, I need one of them to be negative because we had negative 36. So I need to do a positive 9 and a negative 4, right, so that they'll add up to be a positive 5. Okay, so you just got to be careful with the signs, you know, negatives, positives. And so what I'm going to do is split up this 5x into these 2 terms. Okay, 4x squared was still there. Then I'm going to do a plus 9x minus 4x, and then a minus 9. And again, it doesn't matter what order you do them in. You could have put these 2 in the other order, right? You might have had negative 4 first, then positive 9. It really doesn't matter. The grouping is going to get the job done either way. And it might look nicer if we did the other way. Looking at a 4x squared here, if we had the 4x there, it might factor nicer or whatever, but honestly, it's going to end up working out the same either way. Okay, so let's just go with this route. That's what we had. Oops. If we go to our grouping process now, okay, I'm going to look at these 2 terms. The only thing they share is an x. Okay, so we can factor an x out. and we would be left with 4x plus 9. Okay, looking at these two, it looks like they only share nothing, right? Only a 1. So sometimes you just have to bring out the common factor of 1 if that's all that they have. Okay, and just watch again this time, since we need to get a negative 9, and we already have a minus sign there, this one would need to be plus 9. Okay, and this is again exactly what we want. They both share now the 4x plus 9. We have that common factor. Okay, if that didn't happen, then the expression may not be factorable. Okay, if these don't match up, you have no common factor to deal with, you might just be out of luck. So we have the 4x plus 9. Once we factor the 4x plus 9 out, the leftover stuff is the x and the minus 1. That is going to be your other factor. Here's our final answer, and that boy is factored. Okay, so just practice on these a little bit. They do take a little bit of time to really master the concept. It's just a way of to get the job done, like I said. Other things you can try, okay, and when I first learned this, we really did it this way. So we would have, if let's say we knew it started with a 4x squared, I would know that I would need 4x and x, or it might be 2x and 2x. So I would just have to guess and check and trial and error and get all these different options and see which ones made everything work out right. So with using this method, and as long as you understand grouping, like these steps here, it'll just kind of complete the process every time if it's factorable. All right.